All right, so welcome to our first workshop and welcome to this beautiful visualization lab. I hope you like it. Of course, it's going to be much better with every day. So today's different workshop from what typically will be here. And so we plan actually to have a lot of guests on Mondays. Today is a different day because obviously Monday was off. And so we're going to have a couple of guests already lined up. So it's Monday, we have Visual Ignite talks. So on January 22nd, we have Visual Data Literacy, if you're interested in the mapping and data mapping. So that's one talk, and it goes from 4 till 5:15. So January 29th, we have another interesting talk, Visual Science using VOS Viewer. So this person from Leiden University, this is going to be a Zoom meeting. The first one will be actually with a real person physically here. And so this is an upcoming event. More to come, as well as our possibly announcements. So if you sign up on, if you sign up for that email list, I'll post you when it's going to be next our workshops. And I do plan to have a Shiny introduction, Shiny Basic and Shiny Advanced. So today the goal is to, first of all, we all have R Studio. We all kind of more or less know R, but how to make our work, how to optimize it. So that's the main thing. So what's the difference between setting up project versus R script? Because we probably all start writing script, doing our data analysis, go to next script, go to next script, and we have a lot of directories. We have script 1, script 2, script 3. We can find things. So how to make our things more optimizable. Now, how to manage and plan projects. Ideally, especially in this IVMOB course, you have to know how to plan ahead of time, assign tasks, and also time management is very important. And also we'll see how to deploy and share our projects. It's not necessarily just a plot that you want to share, but think about if you deploy the whole website with your project, or if you deploy the whole R document, interactive document, and share with your client or share with your instructor that way. So think about R as more just a script that does the job. Think of R as a project. So that's the idea. And again, I'll announce later on about R crash courses and Shiny Basic and Shiny Advanced. That's for later. All right, so think this is our main idea. So we have our data, right? But it's just one single point in our project, because we have to think of importing, then how to adjust, transform, communicate, transform model data, and then finally deploy and communicate. So it's our main idea. And we'll start from scratch. We'll start from project setup. And feel free after today, go ahead and do your next R task and set up a project. You'll see how it works. Then we'll learn and see how you can actually report and document, visualize, and finally how to share. So we'll start with project-oriented workflow. Again, today is all about workflow. And typically, it's very easy, and everyone who actually has R Studio downloaded able to do that just by simply going to the project instead of file. So that's the only difference, new project. And then you just create new directory, or if you have already your directory set up, just you can use that one. But let's create new directory, and then you select empty project. We just populate, before you start anything, we're just creating empty project. In the future, since I mentioned Shiny, you have options also to create Shiny application, but it's for the future. For now, it's just a project. And then we'll just name meaningfully our directory name and browse to where we would like to have our subdirectory. Now, if you plan on working as a team, there's always a good way of sharing by going and setting up Git repository. It's a great option, again, for version control, for any kind of sharing options, or just back up your files as well. So that's option, you don't have to, but it's a great way of, since RStudio now can communicate with GitHub, so it's a great way of using it. All right, and then we create project. So typically, when you create a new project, even if you had your RStudio open with other scripts already, so you will have totally new, brand new window open, which is kind of nice because it separates your project now from everything else you've done. And all the things you put in that project directory is going to be right here at your reach. So it's very useful. And obviously you can see all the files that will be later, and you already see the GitHub things in that. And since you don't have any scripts, you don't have anything written, it's going to be just 3 windows, right? Console with commands, the environments, and the third window with all help and packages information. So that's the initial step, which is easy. Now, what is possible for you is to actually add some, enhance your directory. Instead of just dropping all the files into your directory or creating your own, let's say, data file, raw data, something else, you can actually use a template build directory, which already set up all the files, names, or all the folders for future files. And this package is project template. So what it does, it creates subfolders in your project already built for your future. So for those of you who never install any library, there's a very easy way of installing a library or package, another way in R we refer to it. So you just go to packages, which is your right bottom window, and you just click packages and install, and just start typing the name of the package, and typically you'll see install dependency already selected. If not, make sure you select that. And repository, typically from CRAN, it's the main repository for R, where you find all the packages basically that you need, or all libraries, and you just install. As simple as it is. Now, after you install library or packages, the next thing you need to activate library. I don't know if you remember that when you install library, it's not active, it's just sitting in your, it's just sitting there waiting. So you need to activate, and one way of activating is just, you'll have to open a script, for instance, and type library in name, or you can go to the packages window and just click on next to the name. Now, what I suggest for you to do to practice later on is to create script, new script. And again, the script is going to be in your new project directory. So when you do that, you open script, obviously new file, just select R script this time. And so let's build folders for our project. So this library is very unique, where you can select your project name if you want. You can actually merge, if you already have your project basically name set up. You don't have to create another subdirectory with the same name. You just merge them together. And in this case, that's what I chose, allow non-conflict, merge strategy. So what it does is you're gonna have the same project you had, my project template, and you have within that same directory all the files that built for this specific project. And one little tip that I suggested, go up one level in working directory. And if you need to refresh your memory how to set up working directory, is just session, set working directory, choose directory. And by selecting one level up from your project where you're right now, allows you to merge that project template with your directory. So this is a lot of words, but when you start using that, you'll see how easy actually it is set up. Now, when you do that, and when you go to your directory just outside of R, you can notice that you have a lot of folders created. They're already pre-built for different purposes. But what those purposes teach you is how to organize your project, basically. And it's relevant not just for R, it relevant for any other project where you're involved with data and analysis. So let's see what they have. First of all, if you have obviously raw data, always try to keep raw data separate from anything else. And so for that, you already have pre-designed data folder. Now, when you process your data, obviously using some scripts. So you would use all the code scripts in Manj folder. And then if you have files that are resulted from preprocessing coding, then you put it in cache folder. Then obviously you have README. And if you've done GitHub before, you know this is important. That's where you describe your project. And finally, you have scripts for data analysis and SRC. In that way, you all organized. You don't have to worry about where the files are. All right. And finally, you also have this rproj. If you notice, that's what we created initially by selecting new project, if you remember. And a couple of conventions to remember or to remind us. So if you have .r, it's going to be R script convention. If you have .md, it's Markdown extension, and rproj is the project extension. Inya?
If we use Git, what should we put into the Git ignore?
For any, yeah, that one, let's keep that question until the end, and then, okay, good. Let's, now, how many of you actually use R, install a lot of packages and have issues with versions that did not work well with your scripts because they were updated to new versions and similar things? Like you update your package and all of a sudden it breaks your code. If it doesn't happen, it may happen in the future because CRAN updates packages all the time, right? And some features may change. Your computer version may change, obviously. You get new one, and RStudio version change. So there's option, especially when you work on client project, and it's extremely important to reproduce the same thing, is in this project site. Now we can install and isolate all the packages that will be relevant only to this package, regardless what we're doing in RStudio overall. If you go to another project, you may have different versions and work on different versions. But for this specific project, we always keep the same version control of packages. And that's what Packrat, and you'll see when you create your project, you'll see that option shown in your window on the right side. It says Packrat, and that's where we can actually install packages just specific for this project. You may notice actually when you start running libraries of packages that all of a sudden you have to reinstall a lot of packages because we're just working with this specific project, which is a great feature to have, again, if you're depending on version control, version type. So what it allows us to, again, have isolation. We just do not have our code being broken because version changes. It's portable because we can just share our project with somebody else. They don't have to worry about anything else, but just reproduce it. And it's portable, right? So if you need to read a little more on Packrat and all the possible features, there is a link provided in the bottom. And now let's move to project planning. Now, since we have everything set up, we need to plan our tasks. So think of our planning as preparation that will eventually help us or basically minimize our work. So our planning is the very beginning, like 1/3. Then we have right up at the very end, kind of 1/3. And you see the programming, I don't know, would you call it 2/3 or 1/3, but it's flatter because it goes from the beginning to the end, but majority of it in the middle. So planning takes a lot of time in the beginning, and it's important since it allows us to start analyzing data in more efficient way, basically. So we need to think of SMART goals. So question to ask first, when we approach any project. It doesn't have to be actually R, it can be your final project on the paper. So specific, is it clearly defined and self-contained? So all the questions you ask in your data analysis, think about, is it specific enough for you to understand what you're actually supposed to do? Measurable, is there a clear indication when you complete the project? Do you have actual product output? Measurable. Attainable, can you achieve it within the time frame that you have? And realistic, do you have enough resources, which can include time, tools, data, all that, do you have enough of it allocated to your task? And time bound, of course. What about completion date? Is it realistic again or not? Interesting diagram, if you haven't seen it, Gantt diagram that allows you to build your planning in a tangible way. We can assign per week or per different time frame specific task and see how much you completed or not. So this Gantt or Gantt diagram can be built by using library diagram R. Very cool library, you can build a lot of different diagram, including this one. And to define it, and this is something I would suggest you to try regardless your R project, but even for like final work, final project, or for some job you're doing. So you will define, first of all, section. And if you notice the word initiation, this is section. So whatever tasks, major tasks you have, like initiation, preparation, major milestone, so that's going to be different section. It's almost like think of it as a title for slide, right? So section and name. So the second, you see the word planning and data processing. So those are individual tasks. And in individual tasks, you can actually define the time when it starts and the time length for it to end. You can define, for instance, 10 days, or you can just give a date. And what it does, so the planning, if you notice, it has you can give a name. I call it planning A1. I did it just for shortcut because now I can refer to it in data processing saying after A1, 30 days. So you can do it that way. And now second line or second section is the date when it starts. In the third one, 10 days. And if you notice planning, it's pretty much a period of 10 days. Now the second data processing, it starts right after the first one and it lasts 30 days. And that's your task. So that's the very useful way of basically planning your task. And feel free to assign different colleagues if you're working on the project as well. I would highly suggest you to go to the Diagram R library. And remember, when you install packages, you can always look at help section, which is in each package. You can click on package itself and there's some documentation. So feel free to study exactly additional features and options that are available. So feel free to do that, and it's another way to learn about packages. Now, for large project, again, if you're working on your own, it's probably fine just to be confined to your project on your computer. But if you work with groups, a large project, you may have division of your tasks, right? You can have different tracking processes or progresses, issues, and priorities. For all that, you need to think about collaborative interaction, right? So these are suggestions, how to do in ascending order by complexity and scope. So we obviously have interactive code sharing with GitHub. And remember, you can link your RStudio to GitHub. It's just a matter for you to configure in it. And feel free to Google exactly instructions. ZenHub, it's a browser plugin that allow you to manage and work with GitHub. So if you're interested in something, just test it out and let me know how it works if you like it. The third way of doing it, again, web-based, and it's very easy to use tool Trello. Anybody here that ever tried Trello? Did you like it?
More fun personal projects. That's the corkboard thing, right?
Mm-hmm. There's almost like you can create little post-its type things on your website and share, but you can assign the task for each person that way. Now, you have desktop project management software. Feel free to look at them, Project, Libre, Gantt project. And finally, for obviously major industrial organizational project, you may look at this open source, open project and Redmine. So this is just suggestion how to organize, even in the future, not just for this specific class, but in the future, it's good to know those tools. We need to also document and report. Why do we need to document? Even for us, providing us with comments, it's very important. Otherwise, 10 days later, we look at the code, we have no idea what we did, right? So that's an important thing in reporting as well. So let's start by looking what's available in R as far as, besides R script. So you notice they have a lot of options. If you have the latest version of RStudio, you'll see all those options. So we have R script, R notebook, R Markdown, Shiny web app, text files, and a whole bunch of presentation event documentation. All right, first, let's jump into simple things, R script. Just to remind ourselves what it does. So when we create R script, we have 4 windows, remember? And on the left window is where we type, it's our editor, left top window. Now for script to execute, and that's gonna be difference between our script and let's say our project, our documentation, our Markdown, it's gonna be different command. So to execute our script, what's command? What do you click? What button do you click? To execute our script? Run. That's what I meant to say. Okay, so to execute our script, you just simply click run. All right, you can do it by line, you can do the whole script. And just to refresh our memory on what's on the right top, or left top for you. So workspace and history, this is you get all the variables that you import or process in your left window. Now on the bottom left is console, where you see the commands and results. On the right bottom, you see all the libraries that you have installed, for instance. You see all the, if you plot something, that's where plot shows up typically. And help is very important. Don't forget to go to help every time you need some information about packages. All right, good. Now, let's see how our script built, because we're gonna compare that syntax and structure with our Markdown later on today. It's important because they're slightly different. So in the way to build script to make it reproducible, we always have to think about structure, right? And it would be great, especially if you're working with the public GitHub, you probably want to have a very clean, organized code that you want to share, especially when you look for a job, right? You can show, that's what I did, and I'm very organized. So that's why the copyright statement, author comment, those are important. Then what's even more important, file description. What is the script for? So this is something that tells you how you able to provide or summarize your script so you understand what it's for. Then other statement, what libraries. So anytime you use a lot of libraries, make sure you put them on the very top so that people know, the users who reproducing your code know what to install by just looking at the top. So, and then finally you have function, definitions, which function is for what, and then statement if you have some plotting and other things. All right. So, one more thing. So when we use the word library, that's the package we are using. If you have external R scripts that you're using or external codes, use source. In that case, you're just calling a different script to execute certain things. That's the difference. Okay. Now, naming is extremely important in some, there's been convention. The community, our community came with the certain convention that everybody agree upon. And if you follow the convention, you're good user of R, basically. So let's look at, so we have different conventions for different functions in different types. So for file names, so whenever you create new file, the good way of doing it is obviously to make it more interpretable and also to use underscores in the naming, all right? And obviously you have .r. When you talk about and create variables, so variable names are, there's kind of preferred versus accepted. So for instance, all small cases with dot, it's preferred, variable dot name, or you can have variable with a capital, second capital for a second word. That is variable underscore capital, also name. Let me see, how many of you using dot a lot in variable name convention? Like say, my dot file. Good, 2 people. How about variable capital N? 2 people. How many variable underscore name? I've done it, so it's bad. But so now we just need to kind of structure our variables in this way. You know why? Because there's a difference between your variable name and the function. So if we follow the same convention, we know when it's function and we know when it's just a variable. So let's look at function names. Typically, we need to use action verbs. Do you know what action verb? Any example of action verb? Swim, jump, you know, action verb. Okay. So good convention is we have, did you notice all capital letters? So if you by mistake have capital letters in your variable names, assumption is it's a function, it's not a variable. So make sure to follow those conventions to be great users of R. And now let's look at similar convention that some people agree, some people think they're optional, but they will not break your code. But again, there's convention. So for assignment, do you use equal sign or do you use this arrow? Equal sign. It works, but people who look at your code with equal sign are going to get mad. They say it's wrong, even though it works. But the idea is to make strong distinction between equal sign being equal sign for arithmetic, like in arithmetical calculation versus assignment. And that's the reason why arrow, it shows you one assigned to another one. Now, within the functions, you may have options sometimes, and options comes with equal sign because it's not like assignment, it's some sort of option. Now, another convention, very interesting, and you probably have seen that annoying, not the arrow message, but the blue message on your RStudio when you forget space between those binary operators. It asks you, give me a space. So you can still run your code, but for certain reason, this, if I just don't have a space here, it still runs, but you notice it kind of complains. It put a little I expected white space around operator. So you can still run it, but there's pre-built convention in it. All right, and now space after comma as well, kind of required not before comma. Now look at the sample, total sum. Can you correct and tell me what should be correct representation of this line? Arrow.
Space.
And space, yeah. So it's going to be arrow and space after comma. Good, and feel free to learn more about style. There's a whole bunch of information, interesting, how to do indentation. Remember, we don't really use tabs to indent, but indentation is helpful to understand how your code is structured, especially if you're using if and loops and for loops. You just use the spaces basically, but indentation always visually helps. All right, and now, so enough about our scripts. And at the very end, let me know if you have any questions. Now we will jump into something that's called our Markdown. First of all, how many of you have heard or used our Markdown? A lot of you. Excellent. Now, it is ultimate R reporting tool. Why? Because it's making dynamic documents in R. It's easy to write, in fact, when we, it's just plain text format with a little bit of notation, and the file can be converted to HTML if you build your website. Here we go. PDF if you want to submit your final paper. It can be converted Word. It can be also converted into your own applications. So all that can be done within R, and I forgot to mention, it can be created as a presentation. So you can have the whole R presentation done in R with all in interactivity and coding in your slides, for instance. So it's very cool things. And if you write a paper using LaTeX, if you have a lot of formulas as well, LaTeX is part of it too. And some people even publish books using R Markdown. I'll show you some examples. So for R Markdown, first of all, if you just simple, if you want to sample, just a simple sample example, when you go to File and New File and select R Markdown, it gives you a sample, good enough to see how it works. And this is one of the samples I have here. So if you notice, you have title, author, date, output, how you want it, PDF or HTML, and then the rest is what's in our Markdown. And the coolest thing is, instead of running it, you knitting it, and when you knit it, let's say to a HTML, it's shown here. Of course, you can select HTML and upload to your website, but it's produced already. All the code you have here, it's on your website, so you can share it. You can make it interactive, etc. So that's one cool things to have. And if you select PDF, again, it does the same thing, except you have PDF file that you can submit as your final project, for instance, especially if you do a lot of statistic or data analysis. If you do regression, it's the best thing to do. And if you do plotting, again, it's one of the best way of submitting your assignment, actually. All right, and then, so if we notice here, so the R Markdown, if it's PDF, it's in PDF, but if you're using HTML, it comes in the viewer space. But also, if you go to your directory outside of R, you can find you have HTML file. And if you have your own place, like a server, you can drop that file and you have basically website with your data posted. All right. Now, if you haven't, I don't know, do you know that GitHub, Stack Overflow, and Reddit all using Markdown? You probably have seen the README file in GitHub. So that's Markdown structure again. So learning it not just for our purposes, but for using in more global environment is very useful in addition to our skills. All right. There's a difference, slight difference between Markdown, HTML, in the way it looks actually when it's produced. So let's look at, so if you work with HTML, you have structure ideas, so which is good. If you didn't work with HTML, it's fine too, because it's different in a way. So if you notice, you have heading, H1 heading in HTML, but in the Markdown, you have heading marked with the line. And let me take you to this Markdown. You can also, 2 hashtags, create a title, like a header as well. So next, and that's what subheading is. Paragraphs just the spaces. You don't have to worry about any external additional tags like in HTML. Then if you look at attributes, like say if you want to have something in italic or bold, right? So instead of EM or strong in HTML, you would use underscore italic underscore, or you use those asterisk for bold. And here's, for instance, see the word neat, and it's bold with those asterisks. And this way, I don't know if you can see here, you have, what's it called, like single quote. So single quote is that monospace, has certain feature. It looks like code, highlighted space with the code within it. So that is created by a single quote. Okay, and as well, numbering lists, a bullet list, all that can be done in Markdown. This is a good start. Go to Wikipedia site and learn Markdown convention and just start practicing, really. That's all it is. And you can embed images and links as well. So think of it, there's no limitation. Basically what you can put in HTML, you can put in R Markdown, and plus, because you can have interactive R code in it. How do you render? That's what we've done actually a couple of minutes ago. So you need two different formats. You need to HTML, PDF, Word. I can't think of any cases where you need Word, but it could be that you need Word document. Now, if you need from that button option, it produced the whole document from scratch. Every time it's almost like re-rendering data all the time, again and again. Now, if you can run specific code in your document. And in this case, you can just run one portion of your data. And if you look here, here's if you see the gray area, that's where our chunk, our code sitting. To embed your R code in R Markdown, you have to use those three single quotes. Then you have curly brackets, and you specify it's R. Because at some point you may use different languages, right? So you have to specify what you're using. In this case, I'm using R, and we asking to summarize this data. It's called car, and you can also click run current chunk, and it produces the same output. The same with the, if you notice this chunk, gray chunk, tells us I would like to have a plot, and you can close it, obviously. But if you run separately, it just produces that chunk. Again, compared to when you need, it re-rendered the whole thing. So if you had a lot of code, a lot of processing it may take a couple of seconds. If you just want to see simple snippets of the code, just do it with run. All right, and good. Now, those R chunks are interesting because you can control what the user eventually see on your document. If you want to share code, the whole code plus the data it produces, just R, and including whatever you define, like dimension. So your final document will have dim as a code plus the data that it produces. If you'd like to just share the results, you will have to specify echo false. In that case, you're not sharing the actual code, you're just sharing the data output. So you can specify that this way. And if using float kind of the same way, and you can specify what kind of float and what kind of, how much code you'd like to use. And sometimes you may have warning messages. If you remember, you install different libraries, you may have different warning messages showed up, like version of R. So you can specify different types, like warning message equal false as well, or message equal false is one of the options too. All right. And this is another link to articles from RStudio that tells you how to use R Markdown in more specific ways. And also you have some sample snippets. If you'd like to write a paper and produce data in the sentence, actually, you don't worry about code chunk anymore. You just want to have the result of your regression analysis, for instance, in the sentence. So the way to do that, you just use single quote, and you build inside that single quote what you're looking at. So in this case, you have R, and what R? I want to know what 2 + 2 is. So in actual output, you'll have 4. So you can keep typing your sentence without splitting sentence and providing chunk and going to next sentence. So it's convenient, and you don't have to, if you rerun your code or you change your data, you don't have to rewrite your paper. Results will be automatically updated. So that's very useful to have. All right, now I'd like us to get some inspiration of why our Markdown is great to start using. I'd like us to look at the gallery. Always think about if you have some project in your mind, but you're not sure what to do, gallery is the great way to start. You can see other people's projects. And let's say you can build interactive documents, right? For instance, why not have interactive HTML built with R Markdown, where you can share with your colleagues the data. So this is document. It looks like document, right? But you also describe data, historic data. You also have, you know how we insert tables in the document PDF? They're not interactive. So here is interactive. You can filter, you can search, and you can also provide interactive visualization, whatever you need. So it's all in the document. And finally, you know, you can do cool things with it, and all done in Markdown and R. So let's look at another option. So that's interactive document. How about dashboard? Do you know what dashboard is? Anybody can try to define what dashboard is?
Overall menu or looking at certain features.
Mm-hmm. So it's like overall overview. It's a good point. And do you know where it came from? Like dashboard. Like a car, exactly. It came from a car. Think about in the car, you want to know everything in one place. You want to know the gas level and temperature. It's all in front of you. You don't want to go to next page. It's right here. So all important information all in one in front of you. And you may have different layouts, but all important data in front of you in the dashboard. So for instance, here's your dashboard. Again, this is dashboard on CRAN users. So every time you upload a package or download package from CRAN, for instance, well, it just tells you how many downloads, how many unique users, and it's streaming, it's reactive. So it's a very interesting way to build your visualization project or analytical project where you enable user to see it in actual changing state. So it's very cool. Let's look at presentation. Have you done presentation in R? So think about, instead of paste and copy images, sharing your graphs, you can actually build your slideshow in R. So this is just example. For instance, table, no paste and copy. It's all reactive. Then visualization. It's all built in R, and you can engage your audience by showing something more interactive. And you can create a lot of things. And let's look at another option. So we've seen dashboards, we've seen presentations, we see documents, and how about books? I don't know, in the future, maybe if you write a book, why not write with R Markdown, for instance, and website. Finally, we would like to have website interactive and engaging. So that's the way to use package flex dashboard, different layouts, different HTML gadgets, and you can, again, use the knowledge of R Markdown as well. Did I convince you? Are you gonna use R Markdown? Okay. So, and also make sure every time you have some questions, just go straight to RStudio. It's a great site to get all information, how to use it. They have a lot of articles posted, instructions how to upload different packages, and basics as well. Okay, good. So hopefully I gave you enough inspiration. Now let's look at data analysis and visualization workflow. Again, when we start with the project. We organize ourselves, right? We set up tasks. Now we got ideas, website or dashboard or document. So we have plan. So now ultimate goal is to place our data in it and visualize it and communicate it. So our next plan is to think about the middle part. So first of all, we all know several functions. Obviously, if you're working with comma-separated files, you probably use read.csv file, or if it's text, read lines, etc. Now, recently, there is a nice package that's been in the community. It's called Tidy or TidyVerse. What I'll tell you in a second. It gives you all the packages you need from import to communicate. It's like the whole package and you're done. Like, just, you don't have to worry about additional things. It allows you to import, to transform, to visualize, to model, and communicate. So, and the way we structure our data from the beginning, obviously we import data, then we have to worry about making sure our data is tidy, and that's the word came from TidyVerse. So data have to be constructed in a good way, structured in a good way that will be no miscommunication of what you want from data and what data actually is. All right, so that means, for instance, for structured data, you have variables and columns and observations and cells, all in specific format. Now transform, that's where it comes when you need it, if you selecting, filtering, doing aggregation with your data, and we'll talk about quickly about dplyr package, which is very useful to do. And finally, visualization with ggplot, and ultimately plotly. What plotly does, it allows you to transform ggplot, which is already awesome, right? I hope you've seen the ggplots and done some, but it makes it interactive. So all I have to do ggplot and then transform it in plotly, and it becomes interactive. Very cool. And let's look at, first of all, dplyr. So data transformation, we may want to filter data. Of course, there's a lot of other options available in R, and you may have used a subset, for instance, data, if statements, but dplyr, which is already in TidyVerse package, allow us to have already pre-made function. For instance, filter. So you can filter by category, you can filter by observation. You can use that one. If you'd like to reorder rows, use arrange. Instead of, like you would do typically in R, you would select number of rows or change the number of rows. If you need to create new variables in your function, meaning you want to produce sum of something, aggregate, you would use mutate. Interesting name. You're mutating, you're changing, actually creating new variable. And you can obviously summarize by collapsing variables to single summary. And probably a lot of you use function, what is it, summary, right? So this is slightly different, summarize. All right, and all that information, again, available on that link for more. And by the way, a lot what I'm sharing with you come from the book by Wickham and Grollemund, and it's written in R Markdown. So it's nice to see that book online, all written in R. So, okay, so we transform our data, we make it tidy, and we transform it. Now we're going to visualize the data. And why are we using ggplot instead of just regular plot and hist? Because it has template that has specific structure, and we can abstract what we want from data and actual data output. Why abstraction is important? Because think of building visualization as a blocks. So instead of every time creating new visualization, then you change your mind 5 minutes later, you need to create another one. So what you do, you build block. First you put data in it. Then you add different coordinates, or you can add different function. So you don't have to rewrite the whole plotting experiment. You just add different blocks, or you just delete different blocks. Data stay the same, but you're just adding what you need or deleting what you don't need. So with that said, this is template actually a good start. So we have ggplot with data, and plus it's how we're adding those blocks. Again, if you don't need a block, you don't need to add this. And geom function, it's our function, geometrical, because think of our visualization as mapping, kind of X and Y and Z's. So then we map, what do we map? We map different variables that are assigned through AES, aesthetic. So which is X, which is Y, which is Z, and how we want to group them, it's all assigned in mapping. The function tells us what type of plot, whether it's a box, whether it's point, whether it's line, so it's all assigned in geom function. Again, you got your template, the rest, it's easy. You just change function or change mapping. All right, so example. So we have our data, ggplot. We have that plus, we're adding new blocks. Again, you can add as many pluses as you want this way. And we have our geom function, which is point. So there's a lot of functions. If you Google ggplot, or remember, you can look at library description. So you can have geom bar, geom line, etc. In the mapping, what do? We add aesthetic mapping from what's X, which tells what's X, and what tells what's Y. It's a very simple structure, but yet powerful because you know where the things are. Exactly. All right. Next is, if you think of your data, like why do you need to visualize data? You start exploring your data, right? So that's your visualization comes first. Typically the best is to start visualizing it first, to explore. Then when you understand your data, you can run some analytical statistic on it. And then you can visualize the output of statistic. So, but again, when you look exploratory, you have different options and you can kind of have different layout. But let's say, what does point tell you? So you look at the point that way, maybe a lot, maybe not. But what if you do bars or histogram? So the second column tells you, looks like 3 different clusters maybe. Maybe there's outliers. So you start digging into data in order to understand what's happening. And then you can actually add geom box plot, and it tells you exactly where, most of the data gathered and where there's really outliers. So your exploratory analysis become more robust because you understand data better that way. So it's always useful to, and the cool thing about it, you just change functions. You notice geom point, geom bar, geom box plot, but the idea is the same. Then you do mapping and data is the same. So it's a very powerful concept, right? And Plotly is, again, something that makes your data more interactive, visually more appealing, and as well, it can be shared online. So if you have a Plotly installed, you can convert your ggplot to Plotly, but first, I'd like to, if you have if you're looking for inspiration, for instance, if you're looking for different type of plots to use, for instance, go to the Plotly site. A lot of times you not only get visual representation, but you also get code behind it. And many times it's not just R code. The same representation can be built in R, Java. I believe they have up to 5 different codes that you can look at. And depending on, again, project you're working, that's another way to learn how to build presentations. All right. And here's our ggplot. So if you look at our basic charts that we mentioned, remember geom bar, right? Remember geom point. Now, what difference? Let's see if you notice the difference. Okay, so this is our geom point. And okay, there's our library, Plotly. And we're just building scatter chart or scatter plot. Obviously, we're assigning ggplot. If you notice ggplot, we have data, we have aesthetic assigned to X and Y, right? And we use geom point, it's our function, and we're just assigning shape equal 1, which is circle, all right? Now, to put ggplot into Plotly version, all we have to do is to wrap it in ggplotly, here's the function, ggplotly, and inside just the name of our ggplot. And when we do so, it wraps it and become interactive. So the same ggplot turn into interactive plot that you can obviously share. And there's different options you can share, and you can zoom in and out, and you can download plots, and etc. So it's a very easy way of making it more interactive. Did I convince you start using Plotly? I hope so, because it's very, very useful and very engaging. Okay. Now let's move to sharing, publishing, and communicating. So if you are right now in our Markdown, you may notice next to run option, you have this blue thing with a dot in it. And it says, if you click on that, it says publish document. You can find the same thing typically on your left, no, on your right bottom window next to, yeah, if you're in the viewer, if you're doing HTML, you have viewer, you have that button. If you're doing page, PDF, then it's going to be on your left side. So clicking on the publish document, it's so easy, I promise. It takes you directly to our pubs option or our Studio Connect. So our Studio Connect is a server actually. And it's something, it's good to have, but you have to set up the account, and I don't think it's 100% free. So forget that. Why not use our pubs, which is free service where you can share your documents, upload your visualization, or upload your project. And I do know there's a lot of more and more courses right now that teach, for instance, visualization and use our pub to submit final projects. In that case, you build it as a document and visualization and analysis on online, sharing website so that anyone can access, and it becomes your project that you can share in the future, especially if you talking about interviews and job markets, so you can share actually your project. So you can share it in GitHub, obviously, but this is another way of doing it. So, and when you publish, so it's free service, it's great, and but also it's visible. So if you have something that you don't want to share, think about something else. But yeah, the idea is make it public and available. So it's a great way to share. All right, and if you go to our pubs right now, you'll see it's probably different because everything that recently published gets to be seen on this website, the first on the first part, and you notice what people have been publishing. So there's some documents, there's some dashboard, there's some visualization. So a lot of interesting documents that you can actually see and maybe get some ideas as well. Great, so that's publishing with our Markdown. So what we're not really covering this time, but you can also publish with Shiny server. And for that, if you remember, when you look at new file, so you could actually create also Shiny web app. What it is, it's more like application software that you built for a certain purpose, obviously. And you can deploy also on a website. And let me show you a couple of things that I published. So this is one application that's publicly available in text mining. So I put a lot of functions that come from text mining, clustering, word clouds, pre-processing, and I just reorganize it the way I'd like to have. And for instance, to make it very interactive, let's look what books are on Google Book on text mining, for instance. And you see what I mean by interactive reactive. So it's pulling right now my search, my query, and goes to online API or API. It doesn't have to be books API. It can be uploading different files, for instance, or images. And then you can have very interactive way of pre-processing. It's written in R with slight difference. Shiny and R require different function, I would say, structure. There's a lot of, if you speak R, you can speak Shiny. You just need to kind of configure a little difference. But yeah, so that's kind of interesting way of showing, hey, there's a word cloud. If you notice, why is it big and in the middle of word cloud? Anybody know? Because it's the most common word and because we didn't clean it ahead of time. So it's another way kind of, hey, by the way, you need to clean your data first before you do that. So it's a good way of teaching yourself too visually. Okay, and in order to just some kind of pre-introduction of Shiny, why to use it, you get free account, free server. It's like our pubs as well. And you can upload up to 5 applications. Think about it, you can create your own software and upload on a website and share. And look, I have 2 applications. Obviously one is running because I was running myself, but there's another one application that's still running. So somebody's using it. Good, so I'm getting popular, right? So you can kind of look at that way to promote yourself and also see statistic, what's happening with your application. So it's kind of a cool way of growing in the domain of data analysis to create some application that's useful, but you can also see the impact of your application. So, and let's look at a couple of things just to wrap up, and then we can have a couple of questions. So this is the course, hopefully a lot of you taken. If not, highly recommend it to maybe do self-paced if you don't have time to do concurrent, to learn visualization from theory to practice. And the second is, so this R for Data Science. It's a free book online, and a couple of links in my slides I have directly to that book, and it tells you how to create your, how to do your project in R in this kind of tidy, very effective manner, including, and I didn't cover, including how to set up your environment, how to optimize our memory, how to do all the, there's more things on visualization, there's more things on transformation. So it's very useful. And obviously to see more theory and practice, visual sense of data, those 2 books, hopefully you have them all in your library somewhere to consult. And also, if you ever interested in what's happening here, follow Kati CNS or follow me, and just look at hashtag IvyMock, just basically events and other things that are happening. And with that said, again, so this workshop is more overview of idea, how to set up projects. So we didn't do much of hands-on, unfortunately not, but hopefully in the future, we'll have more courses specific to different stages, let's say, of R. And let me stop sharing, and I will also stop recording. For those of you who were online, thanks for participating, and I'll post slides in maybe in a couple of minutes online. Thank you.